Hello, and welcome to class on Wednesday. It's me, Mr. Jabs, here again. Hey, we got a test coming up on Friday, so you got to make sure that you're ready for that. Today we're going to do a math review of the four equations we got. So we got work, we got power, we got kinetic energy, we got potential energy. All right, so we're going to go over all of our units real quick. I think we're going to go over two problems, and then just so you know, the last 5 or 6 are going to be like yesterday, where it's the conservation of energy problems there as well. You do have that other review already posted on Classroom. A couple other just housekeeping things. Thing number 1, you had a homework assignment due like 5 minutes ago. Hopefully you have that done and turned in. You have a test coming up on Friday. This is going to actually be due tomorrow. Your participation for today is going to be a little different. And so what your participation for today is going to be is you actually have to call me. All right, so you either have to FaceTime me. So you have to FaceTime me. You have to Google Hangout me. Either of those is fine. I need to actually hear your voice today. I need to actually have a conversation with you today. All right, so not just through email, not just through homework, but I want to talk to you today. All right, so that's your participation for the day, is actually calling and making sure that we're talking to each other. All right, so let's just jump in. Let's see, one other thing before we jump in, actually, sorry. I want to have a Google Hangout as a review tomorrow, so I'm going to post a couple of times, make sure that we're good. One will probably be that 10 to 10:30 time, like we've been set as your guys' class time normally. Today's going to be a little different because I'm talking to a lot of people. But I want to have an actual Google Hangout rather than making a video tomorrow. And if that works, that will be the case, because we're just going to go through the review, and I would love if people were actually answering questions for me. All right, so that's the case there. But let's jump into this real quick. Let's review all of our equations real quick. Work, remember, is going to just be force times distance. So work, remember, when I apply force over distance, a lot of times we're putting energy into our system. So we know work is measured in joules, force is measured in newtons, and distance is measured in meters. None of that is new information to us. That's just a quick review. You should know how to solve everything. You should have the triangle if you want it. So that's up to you guys what you want to do. Next, we have power equals work over time. Now, before we actually get to the units, and we'll talk through the units, but do we always have this work? No. But if we look over here, what do we know? Work is force times distance. So what could this work also be? It could also be force times distance. So I'm going to do force times distance. We're going to end up dividing that by the time, and then we're going to be set and ready to go. All right, so power measured in watts. We know that. Remember, this is a normal W. Work a lot of times will be an italicized W. Work still measured in joules. Time still measured in seconds. Those things haven't changed. All right, so those are my units there. Make sure you know all that for your test coming up on Friday. Next up, we got gravitational potential energy. It depends on 3 things: your mass, your gravity, and your height. Okay? Potential energy is, remember, energy is just the ability to do work. So since work is measured in joules, energy is also measured in joules. So potential energy measured in joules. Mass is just in kilograms. Gravity, we know, is just going to be 9.8 meters per second squared. And my height is, of course, going to be measured in meters. All right, so those are all things that we know, all things that we have talked about in the past. All right, lastly, we got kinetic energy. So we got 1/2 mv squared. We'll go over one of these, solving for the v at least. You guys should be able to do the rest of them. All right, kinetic energy, also in energy, so also measured in joules. Mass, still in kilograms. Velocity is just meters per second. All right, so hopefully we remember all of those units. Hopefully everything is good there. Now, I'm not going to waste a ton of our time going through these problems because you should know how to do them. I know my video yesterday was like 25 minutes. They're not always going to be 25 minutes. This one's going to be 10 minutes tops. All right, so I'll go over a couple of questions. Just wanted to give you some information. But then you're on your own. Ask when you have questions. We'll take care of it. We'll make sure that we're answered. All right, so we're going to scroll down on this actual assignment here. We're going to go to number 6. All right, so 6 says, how much power is used if a force of 40 newtons is used to push a box a distance of 8 meters in 5 seconds? So what are we actually trying to find here? We're trying to find power, which is work over time. Do I actually know my work? Nope, I don't. So since I don't know my work, another way I can find my work is I can do my force times my distance divided by my time. All right? So what's my force? 40 newtons. What's my distance? 8 meters. What's my time? 5 seconds. I know the 5 and the S look alike. Get over it. You know my handwriting sucks. All right, so there's what we got there. 40 times 8, I know it's 320. Divided by 5. Let's plug that in because I know a lot of you are because we're all lazy. All right, so 320 divided by 5. Here we get 64 units for power. We know are going to be our watts. Okay, so that's the case there as we go. So we got 64 watts. Hopefully we're good on that. Let's remind ourselves, hey, number 8 is going to be really, really similar to that one as well. All right, so we're trying to find kinetic energy there. Let's go to number 11 because we're going to try and find the speed. Let's make sure we know how to do that. So what is the speed of an object that has a mass of 20 kilograms and has a kinetic energy of 1,200 joules? All right, so 2 ways you can do this, and I know it depends on who you are, what way you want to solve it. One is we can actually use the KE equals 1/2 mv squared. Other one is I can use, hey, we know the velocity is going to equal the square root of 2ke over m. I'm good with whatever way you use it. I'm going to talk through both of them. Let me get my big head out of the way so you guys can actually see that. We're going to talk through both, see if we get the same answer, and double check it. Okay, so first, what are we doing here? This is 1,200 equals 1/2. What's my mass? My mass is just going to be 20. V squared. If I want to half of 20, I know it's 10. So we got 1,200 equals 10v squared. Let's divide by 10. Let's divide by 10. Sorry, I was in your way there. All right, those 10s cancel, so we got 120 equals v squared. Then I still need to get the v by itself, so we're taking square root, square root. So if I do the square root of 120, I would get out 10.95 meters per second. So I can solve it that way. Let's plug it in over here. We still got square root of 2 times 1,200. This time we're going to divide that by 20. All right, I'm going to guess when I actually plug this in, 2 times 1,200 times, divided by 20. Hey, shockingly, in the square root I still get 120. I'm so surprised. Oh, wait. I'm not. We should get the same answer. We're solving for the same thing, just doing it a little differently. So we get 10.95 meters per second. Shocker, same thing. Right, so that's the case there. So hopefully we understand those. I think a lot of the rest of these should be pretty easy. But let's just scroll down a little bit just so you can see. Hey, starting at 16, we look at a pendulum, and I want to find it. Remember, mechanical energy. Hey, ooh, I didn't write that down. Mechanical energy is what? We just got our potential plus our kinetic. Okay, so, and we know conservation of energy says what? That mechanical energy is going to be conserved. So they were going to have the same before and the same at the end. It's not actually going to change. All right, so 16. We start with it. 17 goes with 16, just so you know. All right, so those kind of go together. 18 goes with 16 and 17. All right, and then 19, 20, and 21. Hopefully we understand. So those are similar to what we did yesterday, but then the rest of them should be pretty easy. You're solving for pretty much every variable as we go throughout. All right, hey, miss having you guys in class. Miss it a ton. Miss laughing, miss joking, miss everything. I wish that we could be together, but coronavirus has us separated right now. And so that stinks, but it is what it is, so we'll get through it. Hopefully we have an understanding. Please call me at some point today. You need to for participation credit. And then also, please fill out the Google. We'll probably ask a question on Google Classroom. So fill that out and tell me what time would work. I'm probably going to have it 10 to 10:30. Let me know if that's good for enough people. If it is, we're probably just going to count that tomorrow as our class. So try and hang out with us 10 to 10:30 and do the review that we have there. If you guys have any questions, let me know.